Good afternoon, lady. Good afternoon, gentlemen. Yeah, thank you so much for having me and to have this honor to make a presentation this afternoon for you, how to make your sand foundry more efficient. So the initial situation. So we have a 3D image. So we heard this morning, dark, dirty, dangerous. We heard also some other variants, but it does not change the things. We use a lot of energy, and yeah, in the end of the day, there are the processes create that the scrap will be at least detected in the end by the shot blasting, not earlier. So when we are talking to be more efficient, then we have some certain demands, which is coming from the society. They want us that we are deducting the energy significantly. Also, the job is an issue. I'm very happy to see also here young guys from Castings PLC, so that we create attractive jobs for the future, which is challenging, and also these are jobs where we are competing with other industries. Yeah, and there's also no doubt about it when you hear the prices which are of products which are sold from China, from India, whatever, we are overlapping into the European market, that we have to do something to be more efficient in the future. Oops, no, this was the wrong button. So the approach that I want to show you this afternoon is number one, is an energy-related optimization of the foundry. This is something what we as a manufacturer can do. Then we have the monitoring of the entire process chain, and all of that has the target to deduct the scrape rate. Yeah, and our approach is that we make the production process or the added value in your system as a constant, that you realize, okay, I put this in and I get this out. Yeah, so this is the idea behind. Well, when we talk about the energy-related optimization of the foundry, then we have different parts in a sand foundry. There's mechanics, the electrics, the hydraulics, and the pneumatics. So what we do, for example, is that we design every mechanical part with FAR and FAM methods. This means we are making a weight and strength optimization of the castings. When you compare a molding line which was made in the 90s, then it was paid by the weight. Yeah. So then we put factor 2, no problem. Yeah, the customer will pay that. Today is the opposite. Means we are asked to minimize the energy consumption of the line, and this can only be done when you make a line as strength as necessary, but also as light as possible. Yeah. So another thing, what we do is that we use. This was just a sample, so there are some other things. I can only give you some samples. It's about the electrics. So you can choose today between electrical and hydraulical components and drives. So within the last years, the electrical drives made a tremendous step ahead. Yeah? So before, when also with condition monitoring, the advantage of the hydraulic was always that, yeah, it is absolutely maintenance simple, and but the efficiency of that is not that high like the electro drives. The electro drives have the advantage to be more efficient, but on the other hand, so the reliability and without condition monitoring, it means suddenly it smells in your foundry for ampere, then you know the motor is gone and you have to replace a new one. But when you have to have these big motors as a spare part, then you bind a lot of capital inside. And this is today a different story when you are working with condition monitoring tools. So, and all of them also made you have very effective gears and the mechanics of that. You have a new generation of frequency converters inside, and this is the biggest approach here, this IA4 motors inside, which are very, very effective. These are the motors. These are also the servo pumps, which are also made a big development step for jumping over to the hydraulics. We made a so-called green button function. This was a bachelor report we do with the university in Siegen. And this is something like a standby function. So when you have the molding line in a standby modus, or you do not drive this with a full power, it switch off pumps and put this in the standby modus and saves so also a lot of energy. Talking about the pneumatics, you know that the consumption or the air is the highest energy waste that you can produce in any process what you have. So better it is that you have, number one, that you choose the right molding process. Yeah. So, and there's a difference when you make a very simple castings or a very sophisticated casting. We as a supplier, we have here for the pneumatical approach a so-called compaction kit. This means we have the choice between an impulse, an impulse on airflow, yeah, and on the other side a mechanical compaction. This is a compaction from the backside of the mold, and this is by a multi-ram, an elastic plate, plain plate, or pressing from the bottom side. Yeah, and coming back to this photo, then products like that can easily compacted only by the mechanical compaction. So when you have a good working multi-ram, then you do not need to use the airflow for that one. For that casting, electromotors, where you have to bring the sand into the corners, you have no other choice than using an airflow or forget it. Yeah. So, but there are also some other things. We talked about the mold compaction. Another approach is also that we are cleaning the pattern by airflow by using efficient nozzles. Is also that they are more effective and deduct also the noise in the foundry. That we are using with a high pressure spraying agent, the release agent on that one, also using a good spraying agent as a used spray on that, and yeah, and find and detect other air pressure consumers in the system and try to avoid that as much as possible. So this is what we can do from the supplier side or from the manufacturer side. So the second approach, these are the tiny little helping systems what we have today in a foundry, based also on the Industry 4.0 architecture and all this technology which came in the last years. So talking about the Industry 4.0 architecture, our plant and control system, which is on top of the Siemens control system, is interacting between your RP system and also can be linked with all the facilities of pouring, the molding, core making, core handling, and also the sand preparation. This system is completely interactive by WLAN or by wireless LAN or whatever. And we can combine that with smart sensors. We can go to the upper system, to the ERP system. We can report, make the data from the purchase department or from the sales department down to the different system, can marry the data together, bring them to the line, can upgrade them, show them in smart dashboards, and etc. Something what created a lot of attraction within the last GIFA is the laser marking. So there are different possibilities to bring a clear identification number on a casting. So I know also DISA has also a system, and so welcome. And so we showed the last GIFA a laser system which enables us to bring a QR code or identification number on the casting. And the good thing is that you can get every data, what you create in the molding line or by the core setters or from the pouring machine, pouring furnaces or whatever. You can collect this data as a file and you can make a history of this casting and store it in a cloud or wherever you want. And later, when there will be a problem on this casting, you have always a complete history and can say, oh, my casting, this product was exactly in the parameters. It was between the lower and the upper limit. Everything was okay. So when you want to blame somebody for the casting, do not blame me because everything was done in the correct way. And I think this is an important thing. But in the end of the day, somebody has to pay the bill. Yeah. Another little sensors and helpers we have. These are vision control system we can place all over the line. There are different ways. It's also a nice talk with Lempe because they have a very powerful system for that. Or something what we also showed during the GIFA, these are mold compaction sensors. These are little small sensors connected in a box, mounted on a pattern plate where you get then compaction information of your current castings inside, where you can say, okay, do I get this, the requested data, yes or no? Complete other way, it's a dashboard. Yeah, so everybody know the big screens in the foundry where you say, okay, we have the shift, we have this product, we have this and this turnover, hooray! Yeah, but this is not the sense of the dashboards. Our idea is that we have different people working in the foundry, and everybody of that needs special information. So the information for the maintenance guys is a complete different as we have for the molding line, for the plant manager, or for the sales department, or whatever. So since that we have this big database underneath, we can concentrate these data and make individual dashboards, information for him, especially when we say, for example, for the maintenance, to take example, that we can say, okay, what are the next jobs to be done? What has to be done today? What has to be done this week? What has to be done this work? Do I have, is anything critical? Do I have any alarms? What is recommended to be repaired? And so on and so on. So, another thing in the line. This is cycle time analysis and energy monitoring systems. So when we are talking about fast molding lines as we installed, for example, for William Lee lines, which are running more than 220 molds an hour, then everything has to be smooth working together. So you, on the one hand, it has to be smooth run, it has to get the output, but you have to avoid that you are overloading motors in the system or drives or whatever. This you are doing with cycle time analysis. There you can see what are the potentials. Can we go higher with the speed? Can we go lower? Have to have slower with the speed because of we need more time for the core setting, for example, or for the pouring process or whatever. This tool is that what we have with cycle time analysis. The same is with the energy monitoring system. Today it is quite simple to take up these different parameters, also the consumption of electrical power, whatever, from the system, and sum up that, bring that in the system and detect from that side, where do I have my main power consumption in? Is that something what I can deduct? Can I use other variants, whatever, and take all the systems to optimize it? And when you see a complete molding line, then there are many, many possibilities to set sensors inside as other samples. We can. All right. So we can set here, for example, when we have for the sand supply, there can be a device which is measuring the sand properties to make sure that the sand has the right quality before it comes inside the machine. In the summer, it can be that you try out the sand, or you have long ways between the sand preparation and the molding line that the sand will dry out. You avoid this with these systems. Then vision control systems. So there are different places to set a vision control system. There can be one, can be on the molding machine on the top to see by contrast if you have any residual sand in the corners or whatever, which is not going out, and where there's a need to clean the pattern. Yeah. Then the classical system is behind the turnover device number one. There you are checking the molding. You compare the actual molded box with with a reference photo, and the system will judge now is the mold okay or not. Yeah. The next system, vision control, is this is the Lampus system. This is excellent. There you make a reference photo after the core setting, after filter setting, and so on, and check up is the mold now ready to be closed. Yeah. So these are typical features, and I guess that when you see the development now, what's going on with IA and other developments, that the GIFA in 2 years will be very, very exciting. So everybody's talking about AI. Nobody knows exactly what it is, but it doesn't matter. So we will make something nice. We will call it AI or the new closes of the Imperia, whatever. But yeah, there will be something. Yeah. So everything of that has only one single target. Yeah. To avoid that we detect the scrap casting latest. So our approach is, when coming back from the line, wherever we are detecting the error in the molding line, that the mold is bad, that we give automatically the system by a tracking and tracing system, this mold is bad. That we do not put any additional effort in this anymore. So This means when we detect here that with the vision control system that there is a broken mold inside, then we mark it as a scrap mold. This means the operators here in the system or core robots or whatever is there will place no filter. We are placing no cores. We are closing the mold, okay, but then the pouring machine, the auto pour or the pouring furnace will know not to pour that. Yeah, and then we are going from here and go straight on to to the punch out to avoid that we occupy any valuable cooling time for that. Yeah. This is the approach. This is the idea, and this works. So. I talked a little bit about the molding machines, what can be done, but there are other things necessary to be done, and we heard a little bit about the melting processes. We hear a little bit also about the sand later, sand reclamation and stuff like that. These are also additional topics and very interesting to make more from your foundry and to use the equipment better and to make most of that. Yeah, as a summary. Yeah. A foundry is not a green place, and it will never be a green place. But we can become better. So I showed you the approaches that we made with the targets deducting the scrap rate and make your process as constant as possible. Yeah. So and I will also be curious myself what's going on the GIFA, what we will show, what my own house will present there, what our group of companies, the Sinto group, will present. And yeah, it will be exciting what's coming next. So, and then my call to you, if you want to change something, please talk with us. Thank you very much.
Thank you, Olaf. Thank you, Olaf. That was fantastic. Do we have any questions for Olaf from the audience? Yes.
The Bueller guys were at the last GIFA one before showing the machine that they said was 30% more efficient in running to make the same casting than the previous generation.
Yeah.
You said one of your molding lines 20 years ago compared to current. What would the energy consumption difference be?
Difficult to tell, sir, because we make mainly tailor-made solutions, so no line is comparable to the other one. Yeah, but this is massive, I think. So as I said, so when in Russia we sold the lines by the price, and they said, okay, come 1 kilo more, it doesn't matter. So this was a different time, but in the Borg it's a different today. Yeah.
Worried about the energy consumption of a molding line when the mounting costs were this and the electricity costs that, but I guess it's all going up. This is becoming important.
Exactly. I mean, when you see this big monsters which are made in the 70s or whatever. So I saw a line in Norway which has hydraulic cylinders, that dimension, and then the pressing head. This was a pure casting. It was 5 by 4 meters, something like that, and you see this is really a tank which is going up and down all the time. This is, I mean, as a mechanical engineer, you say, wow, heartbeat, yeah, super, but technically wise, it's absolutely nonsense. Yeah, it can be smarter today.
Yeah.
Okay. Any questions from the audience? Any other questions, comments?